Okay, for this one over here, I'm looking at it, and they want to know the series convergent or divergent. They're not asking for absolute convergence. So what I'm going to do over here is I'm just going to go for the simplest thing possible, which is to do AST and hope it works out, really nice. But I'm going to use the AST on it. Now, before I do that, I want to tell you there's two things I need to show. And the first thing I need to show, is I need to show that an plus 1 is going to be less than or equal to an. All right? So I'm going to write that down. And by the way, an is equal to the natural log of n over the root of n. All right? So what I want to do is just, look at that. And I'll write that down for you. And it looks kind of complicated. It looks ln. Let's take a look at that. N plus 1 over the root of n plus 1 less than or equal to the natural log of n over the root of n. Well, I'm going to say that looks like a fairly complicated inequality to do. So I'm going to need another way of doing it. Right? Merely what I'm trying to show is it's decreasing. Right? So I'm going to say this inequality looks too difficult for me to do. So I'm going to erase this over here. And what I want to do is I want to write a function down. I'm still trying to do this first thing over here. So I'm going to write f of x down. And I want to know where this is decreasing. Because bottom line is that's what this thing is showing over here. Right? That it's decreasing. All right? All right, so let's keep going. And write this over ln x over the root of x. I'm going to write the derivative down. I'm going to square the bottom, and that would be x. Bring the bottom to the top, that's root x, times the derivative of natural log, which is 1 over x, minus the top, which is the natural log of x, times the derivative of the bottom, which is going to be 1 over 2 root x. All right, I'm going to keep writing this. It looks kind of crazy looking, doesn't it? So I am going to multiply. Well, let's do some simple things first. And what do I see? I see 1 over root x minus the natural log of x. This would be 2 root x. On bottom, you just get x. You multiply top and bottom by root x. So f prime, a lot of work. You know what, I'm going to do 2. On the bottom, you get 2 root x times x. On top, you're going to get 2 minus the natural log of x. All right? So, my analysis really occurs on an interval. And the interval I'm looking at is from 1 to infinity. So I'm going to say over here 1, and I need to do the analysis over here. So I realize the bottom's not causing me any trouble. The bottom's always positive, right? What I'm doing is I'm looking at the top, though. So I'm looking at 2 minus the natural log of x, and I'm wondering, when does that equal 0? Well, let's write this down. It's going to be 2 equals the natural log of x. So that's going to be e squared is equal to x. Well, e squared is a tough number. There's no doubt about it. And e squared, it's 2 point something. So I got to pick a safe number. All right, so e is about 2 point something, but 2 point something squares, So I'm going to say it's between 2 and 3. So the number is going to be between 4 and 9. And I want to pick a safe number there. Now, certainly 9's a safe number, but I'm going to say 8's a safe number too. All right, so I'm going to start forward on the 8 forward. All right. Now, if you do 8 forward, what do I notice about this over here? The bottom's always positive, no matter what I do over here. But 8 forward in this thing over here, and I'm using an integer for a reason, by the way, is going to be negative forever. This is negative. What have I just shown? I've shown this over here. So this is covered. I know this is true, at least for n equals 8. So n greater than or equal to 8. I know that's true for that. All right, we just did derivative over here. What's the next thing I got to show, which is a lot easier for me, is the limit. It's the second thing. We're still on problem number 2, by the way. So I have to show the limit. This is the second thing I'm looking for. The limit as n goes to infinity of an. But let's look at it. This is what an is. That's pretty easy. And I hope you realize that, I guess you could use L'Hopital's rule. Let me just think about that. And the bottom You know what? Let's use L'Hopital's rule on it. All right. So let me get my my eraser out over here, and I'm gonna use L'Hopital's rule, and just to convince myself. So limit as x goes to infinity. This would be the natural log of x over the root of x. And let me just put this L'Hopital's rule, because the top and bottom go to infinity. So I'll put my L'Hopital's rule down. And it's going to be limit as x goes to infinity. The derivative top is 1 over x. And the derivative bottom is 1 over root 2. I'm sorry, 1 over 2 root x. Well, let me put this down for you. And I'm still trying to simplify this. And what would you get? Let's see, you get 2 times root x over x, so you would get x goes to infinity, you would get 2 over root x, which of course is 0. All right, that's not bad. We did L'Hopital's rule on that. So for number 2, I'm going to say the series is convergent. What test did I use? The AST. There was 2 things I needed to show. I showed those things. Again, I had to figure out some n that would satisfy that, and I'm not using a calculator to do that, by the way. But the x would be e squared, but again, I'm picking a safe number, 8. You could pick another safe number, 9's fine as well, by the way. And then second thing we did the first, we did the second thing, the limit, and I had to resort to L'Hopital's rule to convince myself of that. Thank you.